a fiber thinner than a human hair, just made a Chinese stock hit its trading limit 5 separate times in 10 days. Not a battery company, not a chip maker, a carbon fiber producer nobody outside the materials science world had heard of a year ago. And the reason investors couldn't stop buying is the same reason engineers in Japan, Germany, and the United States are reportedly still trying to figure out how this happened at all. For years, the specific tier of carbon fiber involved here was treated by people inside the industry less like a product roadmap and more like a wall, a level of strength and manufacturing precision that stayed confined to research papers and tiny experimental batches, never to mass production, because the failure rate at that level of performance was assumed to make large-scale output commercially impossible. China just mass-produced a material that is roughly 10 times stronger than ordinary structural steel, at 1/4 the weight, and for decades, the entire global industry treated this exact tier of performance as something you could maybe achieve in a lab, in tiny batches, at a price nobody could ever actually build anything with. China didn't just hit that number. China figured out how to make 100 tons of it a year, with a straight path to scaling that up 600-fold. So how did a country that was still importing basic carbon fiber 20 years ago suddenly leapfrog Japan and the United States on the single hardest tier of this material to manufacture? And what happens to steel, aluminum, and an entire century of heavy industry if this stuff actually works the way the numbers say it does? Start with the name, because the name is where this story actually starts making sense. SYT-80, that's what China National Building Material Group, a massive state-owned materials conglomerate usually just called CNBM, named the product its subsidiary Zhongfu Shenying unveiled in March 2026. Zhongfu Shenying isn't a scrappy startup. It's been building carbon fiber in China since 2006, out of 2 main production bases, one in Lianyungang on the Jiangsu coast, and another out in Xining, way out in Qinghai province in China's west. For most of its existence, the company did what most Chinese carbon fiber makers did for 2 decades straight. It played catch-up. It made lower grades of fiber, sold them into wind turbine blades and construction reinforcement and sporting goods, while the genuinely elite tier of the material, the grades strong enough for fighter jet wings and rocket bodies and satellite structures, stayed almost entirely in the hands of a small handful of Japanese and American companies that had been perfecting the process since the 1970s. To understand why that mattered so much, you need to understand how carbon fiber actually gets graded, because this is where the story stops sounding like marketing and starts sounding like an actual engineering wall nobody could climb. Carbon fiber makers use a tier system: T300, T700, T800, T1000, T1100, each step up representing a fiber that's stronger, stiffer, and dramatically harder to manufacture without a single microscopic flaw ruining the whole batch. For years, T1100 sat at the practical ceiling of what anyone could reliably mass-produce, and even that grade was rare air. Torei's T1100G, one of the strongest fibers ever put into a commercial aircraft, reportedly ended up in structural components on Boeing's 787 program, and getting a single batch of fiber that good required controlling a chemical process down to a level most heavy industry never has to think about. It's also worth remembering just how far behind China was starting from. As recently as the early 2000s, China was still a net importer of basic carbon fiber, buying lower grades from Japanese and European suppliers, because domestic production simply couldn't match the quality needed for anything beyond the crudest applications. Beijing responded the way it has responded to plenty of other strategic materials over the past 2 decades, treating carbon fiber as a national priority, funneling research funding into domestic producers, and setting explicit targets for closing the gap with Japan's Toray, the long-standing global leader in the field. Zhongfu Shenying was one of the companies that grew up inside that push, spending years working through the lower and middle tiers of the T-series before ever getting close to challenging the absolute top of the ladder. 20 years of playing catch-up is the unglamorous backstory sitting underneath a single headline-grabbing announcement in March 2026. Here's why that particular number matters so much to anyone who isn't a materials scientist. Steel has been the default answer to, how do we build something strong, for well over a century, because it's cheap, predictable, and everyone on Earth knows how to work with it. But steel is heavy, and heavy costs money forever, in fuel burned, in payload lost, in energy spent moving mass around that isn't actually doing useful work. Engineers have spent decades chasing materials that keep steel's strength while shedding its weight, and carbon fiber has always been the best answer, with one massive catch. The very best carbon fiber, the kind strong enough to genuinely start replacing structural steel and titanium in demanding applications, had always been scarce, expensive, and controlled by a tiny handful of suppliers who had zero incentive to flood the market and crash their own prices. Santi 80 is Zhongfu Shenying's answer to that scarcity, and the numbers behind it are the kind that make engineers stop and actually recheck the math. Independently reported figures put SYT 80's engineering tensile strength above 8,000 megapascals, some measurements pushing past 8,050, which comes out to roughly 10 times the tensile strength of ordinary structural steel. Its density sits around 1.79 grams per cubic centimeter, close to a quarter of steel's weight for a comparable job. Chen Qufei, the Zhongfu Shenying executive who led the SYT 80 program, put it in a way that's genuinely hard to forget once you hear it. A piece of this material about the thickness of a finger, he said, is strong enough to lift an aircraft weighing roughly 80 tons. Compared to the previous generation T1100 fiber, which was already considered elite, SYT 80 represents something like a 14% jump in tensile strength. A huge leap in a field where manufacturers typically fight for single-digit percentage gains year over year. And this wasn't a lab demo dressed up for a press release. China officially unveiled SYT 80 to the world at JEC World 2026 in Paris, the industry's biggest global composites exhibition, the exact stage where the world's carbon fiber makers show up to prove what they can actually produce, not just promise. Company representatives told trade press it was the first time anywhere on Earth that T1200 grade fiber had reached stable, 100-ton level mass production, a claim that effectively challenged Japanese and American manufacturers to either match it or explain why they hadn't gotten there first. The market reaction back home in China was almost immediate and, frankly, a little chaotic. Zhongfu Shenying's stock jumped by its daily trading limit on debut day, then kept climbing so fast over the following 10 sessions that Shanghai Stock Exchange officials flagged the stock for severe abnormal trading fluctuation, the kind of regulatory language that basically means we need everyone to calm down for a second. The cumulative price increase over that stretch crossed 100%. That's not the market reacting to a press release. That's the market trying to price in what it means when a strategic material that used to be a Japanese and American specialty suddenly has a serious, mass-producing Chinese competitor. So why does any of this matter beyond one company's stock chart? Because SYT 80 isn't a novelty material looking for a use case. It's aimed squarely at industries where every gram of weight has a direct, calculable cost attached to it. Aerospace structures, where shaving weight off an airframe translates straight into fuel savings and payload capacity, the same logic that's driven every major leap in aircraft materials since aluminum first replaced wood and fabric a century ago. Pressure vessels, the tanks that store compressed gas, including the hydrogen tanks a genuine green hydrogen economy would need by the millions if hydrogen ever becomes a mainstream fuel for trucks, ships, or industrial processes, since those tanks need to survive enormous internal pressure without the wall thickness and weight of steel. Wind turbine blades, where longer, lighter blades sweep a bigger circle of air and capture more energy without snapping under their own weight, or the mechanical fatigue of spinning through millions of rotations over a blade's working life. Transportation more broadly, anywhere a lighter structure means better range, better efficiency, or more usable payload. And two genuinely fast-growing corners of Chinese industrial policy right now, the so-called low-altitude economy, essentially the drone and electric air taxi boom China has been aggressively investing in as a new transportation category, and humanoid robotics, where every gram removed from a limb or a chassis translates directly into longer battery life, faster movement, and less strain on the actuators doing the work. China clearly isn't treating this as a one-off. On June 28, 2026, just over 3 months after SYT 80's debut, CNBM brought 3 entirely new world-class carbon fiber production lines online at the Lianyungang base, each one targeting a different tier of the market. One line is dedicated to general-purpose fiber, the bread-and-butter grades used across construction and consumer goods. Another is built specifically around high-strength fiber in the SYT 80 family. A third, rated at 600 tons of annual capacity, is aimed at even higher modulus fiber, grades built for deep-sea equipment, deep earth drilling gear, deep space hardware, plus high-end sports equipment and consumer electronics, the kind of premium carbon fiber that already shows up in things like bicycle frames, golf shafts, and camera bodies, but at a performance tier well beyond what those industries currently use. That's a deliberately layered strategy. Let the elite aerospace-grade fiber earn the headlines, while the surrounding production lines quietly capture the more everyday, higher-volume end of the same underlying technology. The Lianyungang facility itself represents a roughly 6 billion yuan investment, close to 866 million US dollars, construction that started back in 2023. And it's designed to eventually run 10 production lines totaling 31,000 tons of annual capacity. That's not a company that got lucky with one product launch. That's a company, and a government backing it, that decided years ago this was a strategic industry worth building from the ground up, and SYT-80 is the proof of concept landing right on schedule. None of this happened because the rest of the world stood still, either, and it's worth being honest about that too. Japanese giants like Toray and Mitsubishi Chemical, along with American players like Hexcel and European producers, have spent decades refining their own top-tier carbon fiber lines, and they didn't get to dominate this market by accident. Toray in particular has effectively defined the top of the industry since the 1970s, building the relationships, the patent portfolios, and the manufacturing know-how that made it the default supplier for programs like Boeing's 787 Dreamliner, where carbon fiber composites make up more than half the airframe by weight. These companies hold deep patent portfolios, decades of accumulated process knowledge, and long-standing relationships with the aerospace primes that make up the most demanding, most lucrative slice of this market. A single announcement, even a genuinely impressive one, doesn't erase that kind of institutional head start overnight, and it would be a mistake to assume Toray or Hexcel are simply going to concede the top tier of the market without a fight. What SYT-80 does is remove the assumption that Japan and the US will always be the only names capable of playing at this tier, and that assumption alone is worth billions in future contracts, negotiating leverage, and supply chain planning across the entire aerospace and defense industry, particularly for buyers who would genuinely prefer a second source outside the traditional Japanese-American supply chain. Zoom out far enough, and this stops being a story about one Chinese company's stock price and starts looking like a preview of a much bigger competitive shift already underway. The global carbon fiber market has been projected to keep growing sharply over the next decade, pushed by exactly the industries SYT-80 is aimed at: aerospace, hydrogen infrastructure, wind energy, and a wave of new transportation technology that all shares one requirement: less weight, more strength, at a price that keeps dropping as production scales. If Zhongfu Shenying can keep pushing SYT-80 costs down the way commodity materials typically do once manufacturing matures, the current price gap between elite carbon fiber and everyday structural steel could start narrowing in specific high-value applications, well before it narrows everywhere else. Aircraft parts first, then pressure vessels and wind blades, then, eventually, and this is the part still genuinely uncertain, maybe pieces of transportation and infrastructure. Nobody currently considers realistic candidates for carbon fiber at all. Zhou Yuxian, the chairman of CNBM, used the language of continued expansion when he spoke at the SYT-80 launch event, describing plans to keep growing both production capacity and international partnerships in advanced materials. That's a company signaling it doesn't see March 2026 as the finish line. It sees it as the starting gun. Whether the rest of the world's carbon fiber industry responds with a genuine competing breakthrough of its own, or spends the next few years quietly playing catch-up the way China spent the last 2 decades doing, is still an open question nobody, including the engineers inside Toray and Mitsubishi Chemical, can answer with total confidence yet. So where does that actually leave steel, the material that's quietly held up basically every building, bridge, ship, and car frame on the planet for more than 100 years? Safe, for now, in the overwhelming majority of what it's used for, because cost still wins most fights, and steel's cost advantage over anything in the T1200 tier remains enormous. But safe isn't the same thing as untouchable. Every material that's ever gotten displaced from a specific application started by losing the fights at the very top of the performance ladder first. The aircraft skins, the rocket bodies, the pressure vessels where weight is worth almost any price, before slowly working its way down toward more ordinary uses as manufacturing scaled and costs fell. Aluminum did it to wood and steel in aviation across the 20th century. Composite materials have been quietly doing it to metal in aerospace and motorsport for the last 30 years. The question SYT80 actually raises isn't whether steel disappears tomorrow. It's whether China just bought itself a running head start on being the company and the country that owns the next several decades of that slow, steady displacement, one high-value application at a time. 10 years ago, if you'd told an aerospace engineer in Seattle or Toulouse that the world's first mass-produced T1200 carbon fiber would come out of a Chinese state-owned building materials company most people had never heard of, they probably would have laughed. The same way plenty of people laughed at Chinese solar panels, Chinese batteries, and Chinese shipbuilding a decade or two before those industries quietly became the ones everyone else had to compete with. Nobody's laughing now. The fiber is real. The tonnage is real. The tensile strength numbers have been independently reported across multiple outlets and confirmed at a major international trade show, rather than a controlled company event. And the production lines meant to scale all of it are already running in Jiangsu province today. What's genuinely still unproven is everything that has to happen next. Whether downstream industries adopt it as fast as CNBM hopes, whether pricing actually falls the way commodity materials usually do once manufacturing matures and competition kicks in, and whether Japanese and American producers have an answer sitting in their own labs that simply hasn't been announced yet, because it's a safe bet none of them are standing still while this plays out. That's the honest version of this story. Not steel is dead, not the West is finished. But the company that just spent 2 decades catching up to the world's best carbon fiber makers may have just quietly passed them, in the one tier of the material that was supposed to be the hardest wall left to climb. Whether that turns into the biggest materials shift of the decade, or one very impressive product that stays a niche aerospace input for years while the rest of the world regroups, is genuinely still being decided. What do you think happens next? Drop it in the comments.